Okay, here we go with a question all about entropy. Okay, unfortunately, entropy is a hard topic, so the questions tend to be fairly straightforward and repeated. As ever, hit pause, try the question, and then when you are ready, HL students, have a go at looking at my answer and see if you agree. Okay, so we have a gas compressed at constant temperature, and we want to know what are the changes in entropy of the gas and its surroundings. So let's firstly have a little think about this. We've got compression at constant temperature, and we're going to start off by thinking about our equation Q equal to delta U plus W. Okay, now if we are going to have constant temperature, what that means is our delta U equals 0. Okay, and therefore our Q is equal to W. Now, why is that important? The reason for that is being important means that Q is going to be less than 0. Why? And again, it's kind of linked to a previous question about work. If we are compressed, the work done by the gas is negative. Okay, the gas does negative work because the surroundings is doing the work on it. If W is less than 0, that means Q is also less than 0 because the two quantities are equal due to the fact we're at constant temperature. So Q is less than 0. And why is that important? Well, because we have this equation here, which is delta S equal to essentially Q over T. Well, if Q is less than 0, delta S is less than 0. That means the entropy is decreasing. And what that means is we can get rid of the top two answers. As you'll have seen plenty of times in IB, there's lots of cases where you can have multiple answers here. We're going to go through them and just decide which one's right, which one's wrong. Now, what about the surroundings? Well, hopefully you're aware that the total entropy is always change is always either greater than or equal to 0. So if the entropy of the gas is going down, that must mean the entropy of the surroundings is increasing, because otherwise the total entropy would be going down. And so in that case, that's why our answer here is C. So really all the work here is done in getting rid of in deciding whether the entropy of the gas is increasing or decreasing. It takes quite a lot of thinking there. We have to use two equations and apply our constant temperature to that. So as ever, please do let me know if there's anything that's unclear there. I'm very happy to answer your questions.